moving towards the another question. The question is on the blackboard. Consider a function from the set of positive real numbers. I have mentioned R plus, that is positive real numbers, from -5, that is closed interval, to infinity for the open interval, given by fx is equal to 9x square plus 6x minus 5. Show that f is invertible and find the inverse of f. Now whenever a function is invertible, we are knowing that it is 1 1 and onto. Okay, so here let me tell you just a small recap for these brackets part. If we are having a comma b, or better is if we are having 2 comma 6 and then we are having 2 comma 6. Now what is the difference between these two? Now these two means 2 comma 6 and this is the closed interval. Closed interval means starting from 2, 3, 4, 5, 6 if it is a set of natural numbers, and from here whatever is in between 2 and that is 3, 4 and 5. So we are here for the open, and this was basically with this bracket. It is closed and for the infinity is always open. So we are always using infinity for the open part. So now let's start with the question. The question is fx is equal to, here I am writing solution. Now it is we are having fx is equal to 9x square plus 6x minus 5, where x belongs to positive real numbers. Now for the first part is for 1 1 function. For 1 1 function. For 1 1 function, dear students, what we did in the algorithm approach, we started with fx1 is equal to fx2, and then at the end it was if x1 is equal to x2. So we are going to prove this for the 1 1 part. Now here let x1 and x2 belongs to set of the real positive numbers, and we have to show that it is given that fx1 is equal to fx2 by the algorithm approach for the 1 1 part. Now let's move it. We are having now, from here we are solving 9 x1 whole square plus 6x1 minus 5 is equal to 9 x2 whole square plus 6x2 minus 5. Now minus 5 and minus 5 are the like terms on the left hand side and right hand side, so they can be easily deleted, or in the other sense you can say minus 5 goes to that side, it becomes plus 5, minus 5 and plus 5 becomes 0. So we are having 9x1 whole square minus 9x2 whole square plus 6x1 whole square, 6x1 minus 6x2 is equal to 0. Here we are having, from these two terms I am taking 9 common, and inside it is left x1 square minus x2 square plus 6 common, x1 minus x2 is equal to 0. Now 9 x1 minus x2 x1 plus x2. What I have used here? Identity for a square minus b square. What the result is? A square minus b square is equal to a minus b times a plus b. And that I have used here. 6x1 minus x2 is equal to 0. Taking x1 minus x2 common, what is left inside? From this very first part, we are left with 9 x1 plus x2 plus 6, only this is left. Now we are having x1 minus x2 is equal to 0, this whole part is equal to 0, and this whole part is equal to 0, and 9x1 plus 9x2 plus 6 is equal to 0. So from this part, very much first part, we are having x1 is equal to x2. Now what about this part? If we are having x1 is equal to x2, and one condition is there for this one, or you can write it 9x1 plus 9x2 plus 6 is not equal to 0. Why it is not equal to 0? Because x1 plus x2 is greater than 0. Why x1 plus x2 is greater than 0? Because we have to take here x belongs to positive real numbers. So sum of the two positive real numbers is always greater than 0. So x1 is equal to x2, therefore function is 1 1. So our first condition satisfies for this, that the function is 1 1. Okay, is it clear for the 1 1 function? Now I am moving for the second part, that is onto function. For the onto function, what we did in the our algorithm approach, we just wrote let fx is equal to y, and then we have solved that part. Now again simple, here I am doing onto function. Now for the onto function, we are having let any number, let it be k, k belongs to minus 5 to infinity. Now what is k? K be any number, k be any number for, let k be any number and it also belongs to minus 5 to infinity for the closed interval and for the open interval. Now we are having fx is equal to k. You can write here y also, because we used y in the last while explanation. I have just changed little bit, fx is equal to k. Now when fx is equal to k, what we are writing 9x square, fx is what it is given, 9x square plus 6x minus 5 is equal to k. Now this becomes 9x square plus 6x minus 5 plus k is equal to 0. Now which type of an equation is this? This becomes a quadratic equation. This is a quadratic equation. Now we are having a quadratic formula. If you remember, it's good. Yes, any one of you? Okay, good. It is minus b plus minus under the root b square minus 4ac upon 2a. So I am directly putting the formula here. What is or you can write it, what is ba? We are having a as a 9, b as a 6 and c as a minus 5 plus k. And now we are putting these terms in our formula. We are getting x is equal to minus 6 plus minus under the root, we are having b square 36 minus 4ac. It is minus 4ac. So minus into minus becomes plus. We are having 36 k plus 5. Now here also I am using a trick to solve the question. Why? You people also can open this bracket. Why I use this one? Just to save the time. Because while attempting in the examination such type of questions, it takes too much time. But we can do the calculations fast by some such means. So because why I wrote 36, that is 4ac. Now 4 into 9 is 36 and c I have kept as it is, because instead of multiplying this, that 36k plus 180 like this one, I can just take 36 common inside the square root and then I can take 36 outside the square root. So taking 36, now basically this is the quadratic formula which I have used, and now this becomes x is equal to minus 6 plus minus 6 under the root 36 I have taken under the root 1 plus k plus 5 upon 3, and this further becomes x is equal to, we are having minus 1 plus minus under the root k plus 6 upon 3, and k plus 6 upon 3, this belongs to R positive. Okay. So, or you can write it x is equal to minus 1 plus under root k plus 6, sorry, under root k plus 6 upon 3, where x belongs to R positive. Now here just look, what I am writing here, k is greater than is equal to minus 5. We are already having that k belongs to this thing, so we have just taken that k is greater than equal to minus 5. Now can I write like this, k plus 6 is greater than 1? Can I write like this, k plus 6 is greater than is equal to 1? This and this is one and the same thing. K, if I am taking 6, I am just subtracting 6 from both the sides because this is an inequality part. If I am subtracting 6 from both the sides, then what we are getting, k is greater than is equal to minus 5. So we are having now, or you can write also here, k plus 6 is greater than is equal to 1 and under root k plus 6 is greater than is equal to 1. Okay. So now we are having x is equal to this part. Therefore the function minus 1 plus under root k plus 6 upon 3 is equal to k and it is onto. This is onto function. So I have proved that the R function is 1 1 and onto both. Now when the function is on 1 1 and onto, now you can write it, the function is, because we have to never to miss any of the step, the function is 1 1 and onto, hence it is invertible, and it is invertible. Dear students, this question was also once in a board exam. So I have proved the first part, that the given function is 1 1 and onto, and with the help of the onto part, now we are going to prove for the inverse part. Find the inverse of the function. Now for the inverse part, you can write inverse of function. Inverse of function is here x belongs to 5 to minus infinity. Let f inverse x is equal to k, and we are getting fk is equal to x. Property for the inverse, f inverse x is equal to k, fk is equal to x. Now again we are moving on the in our same question. Now f, we have written fk. Here it was fx is equal to 9x square plus 6x minus k. Now we can write fk is equal to 9k square plus 6k minus 5. Now fk is equal to x, so we can mention it as a x. Now we are having 9k square plus 6k minus, there is a bracket, plus x is equal to 0. Same thing we have done, we have proved in the onto function. So what k gets, what we get k there, what we get x there. Now here what we get k here, k is, we will be having minus 1 plus minus under the root x plus 6 upon 3. Now you will be getting this from that part. Now here we are having two roots, minus 1 plus under the root x plus 6 upon 3 and minus 1 minus under the root x plus 6 upon 3. So we are going to reject the negative part, because if both are negative, then we are our condition becomes false. We are having set of real numbers with positive, set of positive real numbers. So finally we are getting k is equal to minus 1 plus under the root x plus 6 upon 3. Now remember one thing, if in the inverse part you are using plus minus, then might be they can deduct half marks from your question. So k is equal to minus 1 plus under the root x plus 6 upon 3, where again one and the same thing you can write it. Here k belongs to positive r and x belongs to minus 5 to infinity. So f inverse x is equal to minus 1 plus under the root x plus 6 upon 3. So here we have done our question. So this was a lengthy question, but you can do it in a short time. So this is a question and very important question.